Hello everyone, welcome back to my channel. Today we are attempting stock buy and sell. This question has a lot of variants that even go into the terms of DP. But today, since our goal is to get familiar with the array type questions, we are going with the low end variant. Okay, so let's start with the problem description, and after that we'll discuss the approaches and then finalize with the easiest one and the one with the lowest time complexity and space complexity. Okay, so the question goes like this. The cost of stocks on each day is given in an array of A of size n. Find all the days on which you buy and sell stocks so that in between those days, your profit is maximum. Okay, so in the end, your end goal is like sort of this appears to be sort of like a greedy question. You just need to maximize your stock profits. Okay, by the way, this question has a lot of representations, even the easiest one. I have copied this one from GFG, and here you have an array, and basically you have to return any of a possible solution. There can be multiple possible solution, and also give an example there where we have other answers, but you just need to provide any of the possible solution. Don't get confused by the output one in this example. That just means that okay, your answer is correct. So let's get back to the example here. I'll be using this example only to explain this sort of question. Okay, and we'll be discussing the approach on this example only. So let me just draw this array first. We have an array of size 100, we have 100, 180, 260, 310, 40, 535 and 695. Okay, all right. So what they basically want you is to buy your stock. These are price of the same stock, and they want you to buy it and sell it so that you are able to maximize your profit. Okay, so let's say I'm a trader and I buy my stock at what can I do? Like, I can buy my stock at the price of 100 and then I can sell it at the price of 310. Right, what will be my profit in this case? 310 minus 100. True, and I don't see it being mentioned in the question, but do remember that since it's the same stock, seller can only buy the next batch of stock when he has sold once. What I mean by that is, seller can only buy the next batch of stock when he have sold the one with the 100. Okay, it can't go like this, that the seller has bought it at 100 and again he buys at 180 and again he buys at 260 and then he sells all of them at 310. That can't be the case. So when he have bought one, he need to sell it before he can buy it again, right? It hasn't been explicitly mentioned in the question, but yeah, that is a given because it's the same stock, right? It also makes sense. So seller has bought it at 100, he sells it at 310, again he buys it at 40, right? And then he sells at 695. That is one of the option, right? I'm just trying to explore the options here. So 695 minus 40, right? That can be one of our answer. What else can the seller do? What else can the trader do, my bad? Does he has any other options? Maybe let's say he's a bit of lethargic one and he just buys it at 100 and he sells it at 695. That is also an option, right? So, but the thing is, this way his profit will be 695 minus 100. So does he has any other option? Yeah, he can also do, I mean, let's just say that the seller is not a smart one. He buys it at 100, he sells it at 300. No, he sells it at 260, then he buys it at 535, he sells it at 695. I mean, the possibilities are endless, right? He can do a lot of things, but that is why our goal is to maximize the one. So for now, I have just sort of written down the two most closest answers. This way we will have profit of 210 plus 695 minus 40, that will be 655. My bad if I'm not wrong. Yeah, so this sort of reaches a point of 865, and here what is his profit? His profit is 595, right? So we know that the best way the seller can maximize his profit is he buys it at 100, sells at 310, buys it at 40 and sells at 695. So yeah, that is what the questions ask us. They want us to tell us the coordinates, like when the seller should buy and when he should sell to maximize his profit. If I simply write the indexes of an array, remember the index start from 0. As per our logic, he should buy it at 0, I mean at 100, he should sell it at 310, that will be 3, and again he should buy it at 40 and sell it at 695, that is 6. So that is also the answer that they have shared with us. right? I just hope that is clear with you all. So let me just remove these things so we can discuss the possible approaches. Okay, now the approaches can be endless, but we are going by endless because there are actually a lot of approaches of this simpler question. So let's start with the simplest one. Okay. Okay, one let's start with the brute force approach. What exactly can we do? First thing, what if I say that I want to calculate all the possibilities? How can we do that? We say that the trader buys it at 100 and then he sells it at 180. He also We are just calculating the possibilities, right? So what exactly is going to the profit? He buys it at 100, he sells it at 180, he buys it at 100, he sells it at 260, he buys it at 100, he sells it at 310, he buys it at 100, and then he sells. I mean, we are just trying to calculate all the possibilities, right? And once we have sort of calculated all the possibilities of 100, we'll start in a similar way with 180. So 180 with 260, 180 with 310, 180 with 40, 180 with 535, 180 with 695. And this way, we will be sort of having a variable that will store the maximum way, that will be showing the maximum answer, and then we can add it all up. So that is an approach, but I mean, it is going to take a lot of time and space complexity, possibly the order of n square. So that is why I'm not really going to going in depth for this particular approach. What other approaches do we have in our mind, right? Let's think about this. So there's a very popular approach known as Minima and Maxima approach. To explain that, I think I need to draw it a bit of a pictorial representation of this numbers, this figures. So let's say this is right. I'm going to draw a sort of a mountain, right? So this is 100 and this is 180, this is 260, the value is rising, this is 310, and then at 40 we come bottom, and then we go to 535, and then we go to 695. So right, um yeah, I mean, I think my 535 is way lower, but just try to, I think that will serve the purpose here. Okay, so yeah, what does minimum and maximum approach says is that you need to first find a minimum value, then you need to find the maximum value, then you need to find a minimum value, then you need to find a maximum value. So what can be that in this case is, this can be your, this is your starting point, this can be your minimum one, and then this can be your maximum one, this can be your minimum one, this can be your maximum one. And when you sort of take the absolute difference of these values, these maximum and minimums, you'll get your answer. And how do you find your minimum and your maximum? Basically, I mean, let's see, 310 is a maximum, right? We need to figure out how exactly this maximum, so that's very given. The next value should be smaller than it, and the previous value should both the previous and next value should be smaller than that, right? If I say that the value at I is greater than I minus 1, and the value of I is greater than I plus 1, then this is a condition of maximum. I hope we're clear with that. And what is going to be the condition of a minima, right? This is a condition of maxima. What is going to be the condition of minima? Just the opposite of this. The I should be smaller when it's I minus 1, and the I should be smaller when it's I plus 1, right? By I mean the value at the index of AI. So let's talk about this. The 40, the previous value 310 is greater, the next value 535 is greater. Similar for the case of 310, the previous value 260 is smaller, the next value is of 40 is greater. So this is sort of going to be a condition of maximum and minima, and we just need to linearly find the minimas, the maximas, and at the end just take the difference of the absolute values of these and just add it all up. This is going to be answer. So this is one of the approaches. But the thing with this is, right, I honestly find it a bit more troublesome. Reason being, you need to keep checking these logic again and again, all the elements. So I just want to put emphasis on this again, that this is the easiest variant of this question, right? So there should be a simple approach for this. So let's see what exactly that is. The most easiest approach says that, what I mean, why should we think so far ahead in the future? Why should I say that, okay, I'll buy it at 100 and then I'll sell it at 310? Why should I do that? I mean, this is not a real life, right? You don't have any trading charges, you don't have any these long-term tax rules. I mean, that is not the case here, right? This is just a simple question that asks you to maximize the profit. So the logic here is going to be very easy. You have the complete list of numbers, you have the future predictions, you know what exactly is going to be the price the next day. You come up with a very simple logic. You say, okay, this is my day 0, this is my day 1, 2, 3, 4, 5 and 6. Okay, your logic says that I know the values of the number next day, right? So I will buy the stock today only if the price next day is higher than what it is today, and then I'll sell it tomorrow. Done. So I come to day 0 and I ask you what is the price at day 1. The price at day 1 is 180, which is greater than what is the price today, that is 100. So you buy it at day 0, you sell it at day 1, you have made a profit of 80. Okay, you come at day 1, you say what is the price at day 2. You know that, right? You have an array of numbers, this is not real life, you know the future. So you see 260 and you say, okay, I will buy it at 180, that is the today's price, and then you will sell at 260. So you do it and you made a profit of 80. You come at day 2, you see the price tomorrow is going to be 310, you buy it today at 260, you make a profit of 50. You come at 310, you say the price tomorrow is going to be 40 and the price today is 310, I'm not going to buy it. There is no possible benefit, right? So because you know that the stock is going to plunge, it's going to fall, it's going to hit rock bottom, there's no need to buy it, so you don't buy it 310. You come at 40, right, sorry, you come at day 4 and you see, okay, the price at day 5 is going to be 535, so you buy it. And what is going to be your profit? Your profit is going to be 495. Again, you come at day 5, you say the price at day 6 is going to be 695, you buy it 535, you sell it 695, right? And your profit at this time will going to be like sort of 160, and your complete profit is basically the summation of all these values. And this is going to be the same what it was when you were buying it at 100 and selling it at 310, and buying it at 40 and selling at 695. However, in this case your answer is going to be a bit different. Your answer is going to be 0 1, and then you say 1 2, then you say 2 3, and then you say 4 5 and 4 6. But let me tell you, it is already mentioned, you just need to provide one of the possible answers, right? The output one depicts that your answer is one of the possible answers. That is why they are not they have mentioned a possible solution, not the exact solution. So this is also a solution, and then 0 3 and 4 6 is also going to be a solution. So this solution could have been found using the minima maxima approach. This solution can be found using the greedy approach. But the thing is, at the end of the day, both of the solutions will work, even though the answers may be different, but you know it will work. And the reason we opted for the last approach is because, you know, it's a lot easier. You just need to subtract them and add them, and the only condition is going to be the value at the next day should be higher than what it is today, right? I hope that makes sense with you. If not, do ask me in the comment section. I'll try my best to answer those questions. Now let's go to the coding part, and you know that it is going to be a lot easier. Why? Because we know we just had to do subtract, right? So yeah, let's move to the coding part. Alright, so let's start with the coding. Okay, we have an array A, and then we have a size N. Just change the identifiers a bit. Okay, I'll be using a list. They basically wants the days, right? So I'll be using it. We have to create a 2D list, and yeah, this is my empty list where I'll be appending the list, basically list of size 2 that have the days when I buy and I sell it. Okay, so yeah, let's start with the traversing. Remember, I know the future in this case, so I'll traverse a bit less for I in range of 0 to n minus 1. Cool. Remember the logic, it's going to be the same. If the price at next day is going to be higher than what it is today, that is our answer. So you just need to append it with the values of I comma I plus 1, and yeah, you were sort of done. Return the answer. This, remember the logic. If the price is next day is going to the price today, which means that I will buy it today, I will buy it I today, and I will sell it I plus 1 day. So in a way, my answer becomes I comma I plus 1, which means I is the day I buy, I plus 1 is the day I sell, and at the end I return answer. So answer will sum for this let's say the example 1, right? For it will become something like this, that 0 comma 1, I mean sorry for this, it contains basically lists. So 0 comma 1, and then again 1 comma 2, and then 2 comma 3, and then sorry, I believe 4 comma 5, right? 4 comma 5, and then something like this, 5 comma 6. So that is basically my answer will become, for example 1, right? Now let's try to compile and run this. Yep, so we get an answer output 1, which means the answer that we provided was one of the expected outputs, right? Now let's try to submit this and see if it works or not for all the edge cases. All right, so it's, I mean, this simple approach, it worked for all the 132 cases and we get a score of 4. So yeah, the objective for the array series is right, not to complicate the questions, is to understand what is the easiest way to solve them. I mean, we definitely could have gone with the DP approach or some other approach, but that is not the objective here. We just need to learn how to solve these sort of array equations, and just to get a bit more familiar with the array equation, because the thing is with array, right? Because the thing is, array is going to be a data structure that you'll have to encounter in sort of every question that you solve in future. Yeah, graphs or even graphs are made with arrays, right? Graphs are basically two ways of making, but array is also one of them. So I mean, we just need to get enough comfortable with array so we can solve any sort of question with this, and that is the goal of this array series that we are going through. All right, so yeah, that is it for today, and if you have any sort of questions, do ask me in the comment section. And yep, thank you. And by the way, if I was able to help in any sort of way, do like, comment and share. Thank you.